Hi. So when I was preparing for this talk, I went through the topics of all the talks of NSP in the last 30 meetups. And I noticed that there was not even a single talk about code reviews, which was extremely surprising for me because I don't know of any large-scale production system that is built without code review on every stage. But this can be a good thing that this is probably this talk has come probably at the perfect timing because now more than ever code reviews is becoming a bottleneck, especially because people are using AI to write the code. So before we start, I just want to get to know you guys a little bit better. So can you show with the raise of hands how many of you have written and shipped any code this week? Okay, not a lot of people. How many of you have reviewed at least one pull request in this week? Yes, a lot more. Among the people who have reviewed any pull request, I want to know if you start with the author to understand what's going on with this pull request. Raise your hands if you did actually set with the author. Okay, you did it independently. And raise your hands if you actually pulled the branch locally on your computer to thoroughly check it out. Just on the website. And finally, raise your hand if you feel responsible if anything goes wrong in the pull request that you approve. Great. So this is the right audience for me for this talk as well. Okay. So just to establish some common knowledge so that we have the right definitions for the right words. You all must be aware of what Git is, right? It is a version control and collaboration tool built by the Alice Novartis, who also created Linux. And this amazing tool gives you the magical ability to do time travel in your code base and even traverse parallel realities and merge them at a whim. This amazing open source software is generally paired with a code hosting provider, something like a GitHub, Bitbucket, or GitLab, which helps you put this Git repository on the cloud to help everyone else access it. The most important feature over here, which I'm sure you are all also aware of, is the pull request, or the merge request, or code review, whatever these websites call them. And this one amazing feature helps to propose changes to the code base that other people in the team can actually give you feedback. Right? And this feedback is what we call code review for the rest of the presentation. Great. Okay, now let's answer this, the first question. Why do we even need code reviews? Especially now, there are so many tools, so many AI tools that can perform an automatic code review by themselves, right? But still our teams, get behind us and getting a person to review. They will have code owners, or they will have, a rule like at least 2 approvals need to be done, in order to get it merged. Right? Why do people have this? To get into this, let's go back to the birth of pull requests. So before tools like GitHub existed, people were still working collaboratively, right? In fact, let me just share a terminal here. So here I am on a Git repository. I can just do Git say just to do that. Right now there is it's not a popular command anymore, but if you look at your own Git repo, you probably just have one origin which has the URL of the GitHub or the Bitbucket repository. But this feature was more than that. Earlier, before GitHub, people would have the entire list of all the people who are contributing to this repository over here in the Git repo. I'm sure people who are better users of Git might be aware of this. I myself have used this feature a lot back in college. And then Git also has commands like request pull, where you can just specify the commit ID or the branch along with their URL, and it will create the entire block of information that is required to give the context to someone who is reviewing your pull request. In fact, many of you might not be aware that Git also has a send email command inside it, so that you can send the last commits in your branch as email to the person who you want to get a review from, right? But this has been 15 years that people have been using tools like GitHub. So actually Git remove this command, it's not there anymore. but still comes on auto-complete. You can still see this in their manual pitch. Right? So this kind of shows you why we had pull requests or code requests in the first place. And that is for control. The person who owns the repository, the origin, wants to know everything that is changing in their code base. Right? This is like a primary meaning of what code owners need. If you have a code owner file in your repository, can you show with a raise of hands how many of you have repositories which have a code owners implemented inside of it? Many of you. When I say code owners, it should ideally mean that without their approval, the PR will not get pushed. And the approval should come from every one of the code owners. Right? If only one of the two code owners actually review or approve it, it's not really a real implementation of control. In that case, what you are actually doing is just a knowledge transfer. And this is, I think, the most popular way in which we use code reviews these days. It is for knowledge transfer. I think a lot of you would have, can you just raise your hands again, sorry for that. If your repository has a rule like at least X number of approvals are required before it is merged. Right? Why do you need at least X number of reviews? It's to establish knowledge transfer, a way in which other members also know what's going on in your code. Here, if you look at it, it doesn't just do this dependency resolvement. Like it's not just for so that there's no dependency on one person. It also helps in other matters. For example, if you are someone who constantly reviews other people's code requests, you would be more flexible. You will be able to work on any part of the code base. You would also get higher speed in your deliveries because you will not be blocked on someone else to help you understand that code base or to work on that code base on behalf of you. And one of the most important things that I think, I saw someone who was wearing a on-call t-shirt over here. Right? It also helps you when you are on call. If you have reviewed the pull request in a particular module and something breaks when you are on call, you can focus on actually resolving that issue instead of traversing the code base and understanding where the issue is coming from. Right? This finally brings us to the third and I think the most important part of the code review, and that is readability. When we talk about code quality, this is I think what we are actually talking about. We use a lot of automation tools like formatters and linters to keep the code readable. We also follow and preach about KISS, dry, and solid principles, which are primarily just readability things that help you maintain readability in your code base. We also follow patterns like never nesting or separation of concerns in order to keep the code readable and keep it modular. Now, all of this is just to help us keep the code easier to understand, modify, and reuse later. We maintain this modularity because we know that lesser code means fewer bugs, and fewer bugs means better performance and higher speed of the team. And that is like the final reason why we do code review. It is to maintain correctness and performance. I think if the lib team would have done code reviews very well, as I think Suraj also mentioned in this talk, that is one of the reasons why this exploit was impossible. Is because they did not, understand the changes that were proposed very well. They were something that they did not completely understand. And this particular statement that I said kind of magnifies how important we think correctness is when we are reviewing code, and how low an importance we give it when we are actually reviewing it. If you think about it, the code review interfaces of GitHub and Bitbucket and GitLab don't really help you maintain correctness. For example, if someone has changed a function signature, the code review interface doesn't really show you where all was this function even called. Right? If the person has only modified 2 calls and did not modify 3 others, your code will break in production, and the interface doesn't really help you figure that out. Right? And performance also, it's extremely difficult to understand whether the new code is going to lead to a lot of performance issues or will it not lead to any performance issues. Sometimes we would spend time even over-optimizing some things because we think that it should perform it, but it is not really needed because that code isn't really called that many times. Right? So, nevertheless, we tried to catch any mistakes and try to optimize the performance as much as possible. So let's revise. What are the main reasons for code review? The top reason is control. The second is knowledge transfer. Third is readability. And the fourth is correctness and performance. Now you might feel that your team kind of has the perfect code review process in order to make sure that speed is maintained and all of these problems are not amplified. But let me ask you this question. The last time you raised a pull request, how long did it take you to actually get one problem review? How many hoops did you have to jump? How many times did you have to go back and forth to re-implement the same feature before the pull request was merged? Why did you have to schedule a meeting with the author of the pull request to actually review it? And how many times have you been blocked on someone else in order to ship your own feature? Right? If none of these things frustrate you, maybe you have your company has figured out the perfect way to run the code review. But if it has, please talk to me after the talk. I will want to study you much more deeply. But I have interviewed engineers of over 100 companies, big and small, and it turns out that it is not nowhere. Let's consider the case of Lenskart. I have been working with them to solve their code review issues. So Lenskart has a very ambitious tech leadership team. They have a release cycle of twice a week, which makes speed everything. They measure everyone in every tool based on how much it helps them increase their shipping speed. To get a pull request merged in the Lenskart repository, first of all, your code must build successfully. But after that, you need two approvals. One can be from anyone in the team, but the other one has to come from a predetermined list of pod leaders. Now, what is the problem here? There are actually two problems. One, if you talk to any engineer in Lenskart, they would say that they struggle to get anyone to review their PR. They need two approvals and they can't get one. Why? When they raise a PR, the automation tool automatically assigns the pod leader there. The pod leader is so busy with other pull requests, they don't take care of that. So they post the link of the pull request on the common Slack channel, thinking that someone might find time and go and review this. What ends up happening is everyone is busy, and they think that someone else in the group might end up reviewing it, so why should I? The PR still doesn't get reviewed. Finally, this guy finds someone in that list of pod leaders and someone else in the group who they have good rapport with. This has nothing to do with the code base and how well they understand it. It's just a social thing. How good rapport they have with them, they will just DM that person and get behind them to get the pull request reviewed. Now, because this is the second problem. Now, because this person doesn't really understand what's going on underneath, most of the times, the code is huge, right? The code is huge. A good analogy is that if you get 6 blind people to tell what an elephant looks like by touching it, someone who's touching the ear would say that it is a thin, flappy piece of skin. Someone who's touching the leg would say that it's a thick pillar. But no one actually gets the whole picture. And that's how engineers are in their code base. They don't really understand, nobody really understands the full picture. So there's a very high possibility that the person you brought in to review your code doesn't really understand the code that you are altering. Right? So what they will do, they'll ask you to explain it to them. Now if you are explaining it to them, they are not really validating the readability. They are not enforcing any kind of control. And it's very difficult that they would have any estimate of the correctness or the performance of your code. And it kind of defeats the whole purpose, and the only thing that is still taken forward is knowledge transfer. They understood from you what you've done. That's it. Right? So how do other people deal with this? So there are, let me take you to a conversation that I had with my friend Hardik. So Hardik is a CTO of a very successful startup called FRET. And we were just sitting on a Saturday afternoon in Dew Art Cafe in Kolmogla. And we were geeking out, we are just friends, we were just geeking out about random coder stuff, like why Python sucks and why Rust is so awesome. And in that discussion, we ended up talking about why we love monoliths. We both really love monoliths, how easy it makes it to navigate and search different things in the code base, and how managing versions across different services is so easy in it. That's when he dropped the bomb. He said that as a CTO, because he's expanding the team right now, he's moving from a monolithic architecture to a microservices architecture. I was so shocked that the only words that came out of my mouth after the pause of 30 seconds was, but why? And he said that it's nothing to do with the systems actually. It's not something related to the scalability of their performance and their systems, because the cloud kind of handles it pretty well for their scale, which has like around 20 million daily users. His problem was so the requirements for new features and changes come vertically, meaning that they are functional changes. To complete one particular feature, you actually have to test every part of the code base. And this was leading to a lot of confusion. People were overriding each other's code, and nobody was really aware of what's going on anywhere. And this is why he wanted to break this application down into services, and so that he can tell small teams to completely own a particular service, so that there is no confusion on who should I talk to if something is changing over there, or if who should even be allowed to change something. Now this kind of reduces his cognitive overload in team management, but this leads to problems later down the line. I was interviewing an engineer from Geeks for Geeks. I'm sure you might have heard of that company. They have a pretty big engineering team, around 70-80 engineers, with four big silos in them. The engineer that I was talking to, when I asked him what is the most frustrating part of his job, he said waiting on others. Because he did not own all the services that need to be ordered in order to ship his feature, he had to wait for other people to implement them. And it was never the highest priority for that team, right? So he had to wait weeks, and he had to come back to this feature again and again, stashing his previous changes, going back to the previous branch, and adjusting things so that their work is not hindered, so that they deliver what he wants to ship his feature. Right? This is the kind of problems that people end up with if they implement such kind of silos. So this scoping also does not really work at scale. Now when this problem is big enough, if you are working in a large-scale organization, I'm pretty sure that your company has put in a lot of energies, resources, and create tooling in order to make it easier for you. I'll give you an example of Microsoft. So Microsoft has two internal tools. One is called Ownership Enforcer, and the other is called Merlin. The Ownership Enforcer, for every pull request, it calculates dynamically who are the right set of people to review this particular pull request. Why dynamically? Because when you look at a static code on a file, these people quickly get out of touch. They're reviewing so much code and they're writing so little that when the next time they look at a pull request on the same model that they reviewed earlier, they don't really have the full context. So you actually need people who understand that module very well to review that code. And as your team evolves, as the code evolves, as you add more people to the team, the same person who was added in the code owner's file is not necessarily the best person to review it anymore. So they have this code ownership enforcer within their system, which dynamically finds out the list of best people to review a pull request, and then uses a round robin algorithm to identify two people who are the best people to review this code. It assigns them as reviewers, and it doesn't let you work the pull request without their review. Now this is great apart from the round robin thing. So the round robin thing just means that someone will do it. It's not really a smart algorithm. The other tool, Merlin, what that does is it follows up with just those specific two people on email to get their review. It also does other things. It makes sure that all the other checks are passing, the CI is running, the build is running, tests are getting passed, all of those things as well. But this is like the main feature that people remember it by, that it follows up. If I have to review a pull request, it sends me an email asking me to review that pull request. So I actually remember to do it. Right? The thing is that this also becomes spammy very quickly, and they're constantly working on this algorithm to make sure that there's little spam. If there's too much spam, people stop reviewing again. You receive 10 emails to review pull requests in a day, you review another. If you receive 2, you might actually review that. Right? The experience of engineers at Rubrik was a little bit better. They use Slack for this, And their algorithm was a little bit more smart, so it was a little bit less spammy. They were pretty happy that there was no spam. Whenever they would get a Slack notification to review a pull request, they would just go and review it. And the person that I was talking to was an engineering manager, and he basically said that reviewing code is part of my job description. It is basically the first thing that I do every morning, and as soon as I get a Slack notification to review, I am there to review that pull request. So there things were a little bit more smoother. If you look at what these tools are actually doing, it's three things. One, it has a lot of automation. Things that help you maintain readability, which can be enforced as rules. These tools actually put them in, like formatting, linting, CI/CD, static analysis. It helps you get through a lot of back and forth iterations without having to involve a human person to review. The second thing that they do is dynamic ownership. And the third thing that they do is non-spammy communication and follow-ups. But there's still something missing. Even for them, reviewing a code is a heavy task. It's a frustrating task. It takes a lot of time. It's not necessary that you'll actually be able to understand it. And I think that is the one thing that still needs to be built. That is a way to make it easier to understand the pull request. Among my interviewers, the average amount of time that reviewer takes to understand a non-trivial pull request is somewhere between 20 minutes to 1 hour. That's a lot of time commitment. If you have other tasks on your plate, you'll probably want to move this behind. You want to take it up some other time when you are freer. Right? That's why people are not taking the initiative to actually come up and review code. They also don't know whether which of the pull requests actually need their attention or they would actually understand them. So that kind of becomes a big bottleneck. That's why I propose two things to make it easier to understand. One is adding context. If when coming on a pull request, you already know what is this for. A lot of people link Jira tickets to make this easier. So that at least you know what this author is trying to do. Right? But then there is more to the context. It's not just about what is this person trying to do. It's also about what the current code base that was being ordered, how was it interacting with the rest of the system. What was the traffic at different parts of it? How critical are certain systems compared to others? Without all of this information, their review is actually not that good. And the other thing is personalization. If you don't have a personalized context management, you will either give too much information that person will not actually read it through, or you will give too little information that it will not be enough for someone to understand what's going on. Right? So personalized context is something that I believe that still needs to be added on code reviews. And actually, that is what I'm spending all of my time these days. I'm creating a tool called Vibinex that currently just has two things. We have a lot of features in the pipeline, but it kind of, first of all, does non-spamming communication. So if you have a pull request, it adds comments. It adds a comment telling you who are the relevant reviewers in this and what is the relative relevance. This also helps someone who wants to review, but there are 20 pull requests open. Which one should I review? It answers their question that, okay, you are 70% relevant for this pull request. You probably give your time and attention to this one. And it also adds them as reviewers. And in the future, it will send emails or Slack notifications as well in order to follow up with them so that they review this pull request. And the second thing it does is personalization. On the code changes view of GitHub or Bitbucket itself, it highlights the files and the changes that this person has previously worked on, so that they can navigate the pull request in a manner that makes sense to them. This is just the tip of the iceberg. We just launched this in January, and a lot of things are in the way. And what I really want you guys to take away from this talk is three things. The next time you are at work, I want you to take initiative in reviewing pull requests. You know from your experience that how frustrating it is if you have raised a pull request and it takes a lot of time to get that clear. Right? So take initiative. Look at the pull requests on your own. The second thing I want you to do is please don't sit with the author. I think most of you already follow this. But if you sit with the author, you are not really validating the readability of the pull request anymore. Right? You are just hearing their story and you are kind of biased when you are doing that review. You might end up skipping certain things and letting security vulnerabilities inside your code. And the last thing is, because this can make your code review a lot more challenging, use processes and tooling that help you understand the changes better. Get the author of the code request to add context about your code request on the review itself. Communicate with them in order to make sure that it's easy for you to actually review it. So we are building this open source, the Vibinex platform that I'm talking about. Right? And I want you guys to come and join us in that if you're passionate about code reviews or if this is something that is necessary for you. This thing is going to be a bigger problem in the future, especially with AI doing a lot of writing work, and especially because the main job it cannot really be automated. Reviews have to be something that humans have to do. Without that, there's no knowledge transfer, there's no control. Right? My contact information is on the screen. Please reach out to me. I would love to talk to you and understand this further.